a little bit of source code here and there, and this USRP hardware or any other software-defined radio can receive and decode the actual GSM data that is transmitted over the air. So I could try now to actually capture the network that we're running here. I fear it's probably going to take me a little bit too long. Also, the signal reception is very low in this hall. So I think it's more efficient to just take questions and to address your questions, or if you have any kind of make a phone call. But I can make, well, the signal reception here is relatively low, and the quality of the software decoder also is relatively low. So if I sorry, my handset has a big signal? Well, I can tell you I have a relatively low reception in here, but I can nonetheless, if you insist, I can give it a try. But the location in here is not very good to capture the actual signal. The mobile to cell direction has not been implemented so far. It's only the downlink coming from the BTS. The uplink has not been implemented in GSM receivers so far. Of course.
If one were to implement this to get as much call data as possible in a typical urban environment, how many of these USRPs and what kind of calculating power would be needed just to capture, not doing decryption or get the WAV files, but basically just to get the encrypted frame?
Okay, so the question, I'm just repeating this for the audience, the question was, in a typical urban environment, how many of these setups would you need to get coverage of all the voice calls? Now, GSM has really many different channels. In an urban environment, the channels are typically very densely used and densely packed, so you can easily estimate a couple of hundred of GSM frequencies are in use in parallel. And the software that we currently have can decode one of these frequencies. Now, the hardware has the capability to capture a number of more channels in parallel. So you can capture, let's say, using a realistic decimator, you can probably capture, it's 200 kilohertz spacing, it's 4 channels per megahertz. So I would say something up to the level of 32 channels is definitely something you can still capture with a single board and just write it to disk. And if you extrapolate that, you probably need at least 10 of these boxes installed at a single location to get a relatively to get a reasonable proportion of all the phone calls that are being made in that very location. So it's still something that's doable. It's not like you need, thousands or hundreds. It's in the tens of number of units you need just to save and store all that data. The storage capacity also is not that much of a problem anymore these days. As you know, the hard disk capacities are increasing so fast. You can easily get a couple of terabytes of storage and put it here on this desk or underneath the desk. And so actually doing offline analysis becomes a very viable option. So if you know that somebody's going to make a call in this area at a given point in time, you can go there, you can deploy your 10 boxes, you can capture all the data for an hour or two or whatever amount of hours, and then you can take all that home and have a couple of machines offline do the actual decoding and further process on eavesdropping on that. So generally, as I said, the tools are here now. They're very primitive still. As I said, the user interface is very clumsy. So if I want to actually decode the signal, the first thing I have to do is go into spectrum analysis and see where the carrier frequency is located, because it might be shifted a little bit from the clock. There's many manual steps involved in this. And after the manual steps have been performed, you can make it work, and you can actually get a reasonable output. But basically the proof of concept is here. The tools are available. It's now up to the community to optimize the tools, to automatize the manual processes, and then combine the result of that work with the work of the crypto analysts who are on their way of having a very practical solution to breaking the A5 crypto. And once those pieces come together, I would say in maybe a year, maybe 2 years from now, you will have a Kismet-like setup for a relatively few amount of money. Yes?
Could you tell us which modulation schemes at the moment are possible to decode? Because basic GSM modulation schemes apparently work, but for example, Edge uses higher level modulation schemes which are not so trivial to decode. And I don't know, for example, could you also tell us if GPRS decoding in the like aggregate states is also possible? Okay, so right now the software is all centered around GMSK, the Gaussian minimum shift keying, which is the modulation scheme employed by traditional GSM for SMS, voice calls, and so on, data calls even. GPRS and Edge, well, GPRS still uses the same modulation, but has different encryption and different other aspects. Edge definitely uses a different modulation scheme. It's, I think it's QPSK or 8PSK, something like that. GNU Radio has modules for all these standard modulation systems. So there is a decoder for QAM and QPSK and all the various standard digital modulation formats. It has not been implemented in the GSM decode yet, but the basic building blocks are there. You need to work on the synchronization and on the actual error correction bits and so on. But that is a next step. I think right now diversifying to different modulation schemes would be probably the wrong approach. First, get the GSM, not just a proof of concept and something you can demo, but actually a working implementation that removes the manual fiddling and optimizing and setting and whatnot. Get that into a very practical shape, and then you can go on for a GPRS. What has to be noted, though, is that the cipher used on GPRS is a different cipher than the one that's used for a GSM, right? So all the work that's currently being done is for GSM voice calls and SMS and traditional data calls, but it is not directly, you cannot directly abstract from that onto GPRS. Okay. Thank you very much.
Yes, hi, great stuff, thank you. I have a question. I'd like to know, would it be possible to use the device you acquired on eBay in combination with OpenBSC to sniff packets and interpret them at the same time?
No, that is not possible. The GSM is a very asymmetric architecture. The receive and transmit frequencies are completely different. So in your handset, the transmit frequency is 45 to 80 megahertz different from the receive frequency. So a handset has receive and transmitters at the opposing frequencies than the BTS. So that's one of the reasons why even if if you crack all the software on the handset, you could never make the handset appear as a BTS in the network. It's a physical limitation. And also, if you want to do sniffing of the downlink, what's coming from the BTS, you need to be a handset-side receiver. And if you want to sniff from what's coming from the handset, you need to be a BTS-side receiver. So if you use any of the two end equipments, like BTS or mobile station, you can never receive both directions with that equipment.
Hi, you mentioned frequency hopping earlier. Do you currently have support for following that? And if not, what's missing that you're going to need?
I unfortunately did completely not understand your question.
Do you currently support frequency hopping?
Do we support frequency hopping? Was that the question?
Yes.
Yeah, the current receiver implementations do not implement frequency hopping yet. There's different approaches how to solve the problem. One approach is to actually implement the frequency hopping in the USRP and then just download